Hi guys, welcome back. It's the same day. It's just in the afternoon and the evening, and I watched the two videos that I uploaded. I got cut into two pieces, unfortunately, and I saw that the quality was pretty bad, and the notes were all over the place. So I'm gonna try to just do it over. Okay, I'm gonna try to give you guys a more straightforward lesson, if you will. But I will need your help because I'm gonna go a little fast, so you might have to pause and catch up and then press play again. Okay, so you need a sheet of paper. Of course, your paper should always have. Okay, sorry, that was my phone ringing. It's like tons of interruptions, but I don't think that looks good. So I'm gonna leave the light on, but uh, you need that sheet of paper. Go ahead and put your name, period, and today's date. I'm going to number the notes from now on. Okay, so this is notes number 1. It's going to be graphing absolute value functions. Your homework is going to be written at the top. This is tying in with the calendar. This is Unit 5, Subunit 1, and we're going to learn how to graph absolute value functions from today all the way up until Friday. So from January 11th through January 15th. Okay, so your objective, from now on, I want you guys to get into the habit of always heading your papers, writing down the objective. We will have a daily objective, and our objective for today is to be able to tell the key characteristics of an absolute value function. Okay, so today you're going to be able to tell the key characteristics of an absolute value function. The key characteristics are, hopefully you guys know them by now. We've seen them over and over. They are domain and range. What else is important? The vertex. You need to say whether a vertex is maximum or minimum. You're going to talk about symmetry. And symmetry for an absolute value function can be about the x-axis or the y-axis. And intercepts is another concept, another key characteristics. There are x-intercepts and y-intercepts. And then the very last thing that we're going to talk about, which is a little bit new for you, it's called concavity. Concavity just means, does the graph open up or down? Okay, so if it opens up, it's called concave up. If it's opening down, it's called concave down. Go ahead and take a minute to write this down. Okay, so for the practice problems today, you're going to determine the vertex, whether it's a maximum or minimum, the intercepts, the x and y intercepts, the domain and range, symmetry, and concavity. Okay, to kind of refresh your memory a little bit, I want you to determine the domain and range for this function. If you have f of x is equal to x squared plus 4. First of all, what kind of function is it? That's right, it's quadratic. Okay, so that means it's opening up or opening down. It's opening up because x squared is positive, so that means that the concavity is positive. It's opening up. But the plus 4 means that it's going to be shifted up 4 units. So the vertex is actually at 0, 4, and our graph is pointing up in a parabola. Okay, so the question is, what is the domain and what is the range? So in this case, the domain are all the x values. So the x values go forever to the left and point forever to the right. So if it's going forever in both directions, that means that the domain is from negative infinity to positive infinity. You can also write the domain as all the x values that are bigger than negative infinity and all the x values that are less than infinity. So when you put those two together, you have all the x values that are in between negative infinity and positive infinity. Okay, the range is dependent on the vertex, depends on y coordinate. of the vertex. So for example, in this case, what is the vertex? The vertex is a minimum. It is the lowest point on the graph. And in this case, the vertex is 0, 4. The y-coordinate of the vertex is 4. So that means that your range is going to go from 4 to, does it point up or does it point down? In this case, it's pointing up, so it's going up towards positive infinity. Infinity can never really be reached, so that's why we use parentheses. However, 4 is a solid dot. It is included in the function, so we're going to put a bracket. The range has to do with our y values, and the y values start at positive 4 on the y-axis and go forever up. So it's going to be all y values that are greater than 4. All y values that are greater than 4 and all y values that are less than infinity. When you put those two inequalities together, you get all the y values between 4 and infinity. So that's it. That's your recap on domain and range. That's probably what students struggle with the most, is domain and range. But I hope that little recap kind of helped you remember, refresh your memory. And now we're going to try it on absolute value functions. Okay, the next part is our notes. Actually, for the absolute value function, this might take you a little bit of time, so you can pause it to copy this down. But this is a good template for what I want you guys to do for every problem. For every problem, I want you guys to determine the vertex, the maximum or minimum, domain and range, concavity, does it open up or does it open down? What are the intercepts? What's the x-intercept and the y-intercept? And then what is the symmetry? Is it symmetric about the x-axis or the y-axis? We're going to make a table of values for each function, and then we're going to use the table of values to graph the function. And at the very end, we should be able to tell the transformations from the original parent function, which is this one, to the child, okay? So if we start with 0, the term absolute value means that every value is going to be absolutely positive, okay? So always positive. Absolutely, okay? And really, what absolute value means is just the measure of distance from 0. So if on a number line you have 1, 2, and let's say 3, what would be the distance from 0 to 1? So in other words, the absolute value of 1 is equal to, well, that's right, it's just 1. The distance between 0 and 1 is 1. If I asked you for the distance from 0 to 3, or what is the absolute value of 3, you would just say 3. The distance from 0 to 3 is 3. And it works the same in the direction to the left. So what is the distance between 0 and -1? Well, the absolute value of -1 is actually a positive 1. The distance between those two numbers is 1. Distance is always measured in positive numbers, okay? Distance cannot be negative. You don't say, oh, go negative miles. You go, you know, that I walk negative miles to Parkland. Like, no, you walk 1 mile to Parkland no matter what direction you're going, no matter if you're going to school or you're going home from school. The distance that you have to walk is the same. Okay, so distance is always measured as positive. If I had the distance from -3 to 0, what would be the distance between -3 and 0? It would be 3. Okay, so that means that the absolute value of -3 is actually going to be equal to +3. Okay, so with this information, you're going to use it to graph your function or make your table. What is the absolute value of 0? When you plug in 0 into here, the absolute value of 0 is 0. So that's your first ordered pair. What's the absolute value of 1? We already figured that out. We said it's 1. So the absolute value of 1 is 1. So we plot our next set of coordinates. The next set of coordinates would be, what if x is equal to 2? Well, if x is equal to 2, what's the absolute value of 2? It is just 2. If I have x is equal to 3 as my input into my function, the absolute value of 3 is 3. 3 is my output. So I'm going to plot 3, 3. And if you notice, it is a straight line going up and moving to the right. Okay, so my domain includes all of the positive real numbers. Does it include the negative real numbers? Well, that's what we're going to see. If I let x be equal to -1, what is the absolute value of -1? You guys told me the distance between 0 and -1 is +1. So now, when you plot your points, you're going to have a dot at -1, +1, at -2, +2, and then of course if you let x be equal to -3, the absolute value of -3 is a +3. So the distance between -3 and 0 is +3. So you plot your points there. If you notice, on this side, it's also a linear function moving towards the left and moving up. Okay, so your parent function for the absolute value always looks like a V. Okay, it looks like the letter V. Usually the parent function, well, always the parent function will start at 0, 0 at the origin, but it will move up, down, left, right, okay? It will be flipped over the x-axis. I mean, it will be stretched, compressed, okay? So those are some of the vocabulary words that we've seen in the past. Okay, so we're going to fill in the information. What is the vertex for this function? The vertex is here, so that is going to be 0, 0. Is this a maximum or a minimum, this point here? Well, it's a minimum. It is the lowest point on the graph. The domain are all the possible x values. My possible x values included negative numbers and positive numbers. They move forever to the right and forever to the left. So that means my domain is always all real numbers. Okay? We need to practice writing that down as a set notation and inequality notation. So in order to write domain, my function is going from -infinity to +infinity. Or you can write that all the x values that are greater than -infinity. Or you could say all the x values that are less than +infinity. When you put those two inequalities together, you're saying all the x values that are between -infinity and +infinity. All right, the range depends on the vertex, on the y-coordinate of the vertex. So very similar to the quadratic function, the range depends on the y-coordinate of the vertex. It's the same thing for the range of an absolute value function. So your vertex starts at 0, 0. This is your x-coordinate, this is your y-coordinate. Your y-coordinate is 0 in this case. So it's all the y values from 0, and now is our graph opening up or is it opening down? This parent function, it is opening up, so it's going up towards +infinity. +infinity and -infinity is never really a real value, so we're going to put parentheses, but the 0 actually comes with the bracket because it includes that point. It is a solid dot. It's in our table, and so it's included in the function. Another way to write this is all the x values that are greater than 0. That's one way. As an inequality, you can say all the x values that are less than +infinity but greater than 0. Okay, your x-intercept occurs at 0, 0. Your y-intercept also occurs at 0, 0. It is symmetric about this side on the right looks the same as the other side on the left. So that is symmetric about this axis, which is the y-axis. Okay, I'm going to stop there, upload this, and then I'm going to give you part 2. Thank you. Get another, or go ahead and start writing on the back of this paper, or pause this and write down whatever it is. Whatever you need to write down so you can catch up. I'm going to upload part 2, okay?